Welcome to my student. Today's lectures we have discussed the topic stereochemistry. In this topic we have learned the Z and E nomenclature. Z and E nomenclatures which is on the basis of cis and trans of the geometrical isomers. So these geometrical isomers we can contains at least two similar groups on the same side. This is called as a cis isomer, and they are opposite side. This is called as a trans isomer. But ZE nomenclatures it may be used to given the nomenclatures by doubly bonded carbon atoms. They are arranged on the decreasing order of the atomic norm. So this decreasing order given the priority on the basis of their atomic number. Now, the position of the group of higher priority to one of the carbon atom are compared to a similar priority to the higher group attached to the other carbon atom. So higher priority group are on the same side, then its structure is designated as Z. Right? This is Z is a design Zusman, it means together, is a Greek word, or German Zusman, and E is designated as in the form of anti-zing, it means opposite. So this is mainly given the priority on the basis of their atomic number. Now this is the one carbons which are bonded to carbon-carbon double bond with other carbons. So given the priority, so this is the first because carbon having the highest priority, and this is a second. Similarly, carbon having a first priority, right? And this is a second priority. And hence, highest priority group on the same side, like this. This is the structure is designated as the Z. And highest priority group is on the opposite side is designated as capital E. So these Z and E can be designated as on the basis of their priority. Now we have seen some other examples for given this the Z and E notation. Now first examples we compare these two atoms. So first priority is carbon, second priority is hydrogen. Similarly, the bromine is first priority, chlorine is second priority, because atomic number of bromine is higher than chlorine. So highest priority group is on this same side, 1 on same side, so it is designated as Z. Then secondly, the highest priority group, these carbons 1 and this 1, they will opposite side, so it is designated as E. Similarly, we compare this. फक्त आपण शेजारच्या ॲटमचं कंपॅरिझन करायचं. ह्या दोन्हीचं कंपॅरिझन केलं तर ब्रोमिन इज फर्स्ट, हायड्रोजन इज सेकंड प्रायोरिटी. ह्या दोन ग्रुपचं जर आपण कंपॅरिझन केलं तर फर्स्ट प्रायोरिटी इथिल, सेकंड प्रायोरिटी मिथिल. सो फर्स्ट highest priority group is on the same side, so it is designated as Z. It is similar, we compare this. So first priority is given 1, this is second priority, it is also one priority and second priority. So highest priority is on the same side, so it is designated as Z. Similarly, it is here, we compare this, bromine is first, hydrogen is second, this is methyl is first, hydrogen is second. So similar group on the same side, highest priority group is on the same side, so it is designated Z. Similarly, this is a highest priority group is on opposite side. This is a 1. This is also 1. Opposite side. So it is designated as capital E. Next, so we compare this. Bromine is first, atomic number is highest, bromine is first, hydrogen is second. This is similarly OH, oxygen is first, this is second. So highest priority group is on opposite side, designated as capital E. Next, this chlorine is first priority, hydrogen is second priority. It is similar, hydrogen is second priority and ethyl group is first. So highest priority group is on the opposite side, so it is designated capital E. In these examples, they will show this methyl group is first carbon atomic number is 6, hydrogen is 1. So first priority this, second this. Chlorine atomic number is 17, carbon is 6, so this is first priority. So this highest priority group is on the same side, so designated as capital Z. It is here similarly, this is highest priority group is on the same side, so designated as Z. Similarly, this is the highest priority group is on the opposite side, therefore it is designated as E. These examples also, the highest priority group is on the opposite side, so designated as capital E. So the one mentioned that the highest priority group is on the same side is designated Z, and highest priority group is opposite side is designated as E. Now we have see next point, we have discussed the Newman projection formula and Saw-Horst projection formula. Now this arrangement of these atoms or the groups in this space, they can by rotation about a carbon-carbon single bond, which is called as a conformation. The compounds having the 2 or more carbon atoms have a different configurations. They can be represented by the Newman projection formula. But the molecules can view along the axis, they can join 2 atoms. That is, one atom is capital A, second atom is capital B. The front carbon's atoms are joined by the center, that is this center, and rear carbon's atoms are shown by periphery. And hence Fisher can be convert Newman as like this. So these parts now we have seen previous lectures, or this is previous slides. As like this, 2 methyl groups which are below the plane. This is one of these atom is above the plane. This is left hand side, this is right hand side, left hand, right hand. So these Saw-Horst you can write in the form of Newman projection to use is a staggered form. And these Saw-Horst, this methyl group is below the plane, this methyl group is also below the plane. So this is on the same side, which are near to each other. This OH is red color and this OH is red color bond, also which are same side. This left hand side and this is left hand side blue bond. So this blue bond, this is blue bonds which are near to each other. So this structure is called as a eclipse conformation. Now we have discussed the conformation of ethane. So ethane molecules which are joins the 2 carbons having 3 hydrogens of each carbons, like 3 hydrogens, 1 this. So 2 conformations are possible. One is a staggered form and second is a eclipse conformation. But ethane molecule has 2 methyl group. They are attached by these single bonds. One carbon rotate around the CC bond while keeping other atom, it will be constant or stationary. So they give us 2 different conformations. They can be staggered or the eclipse conformation. But you know that staggered conformations is more stable than eclipse conformation, because in staggered conformation we observe that all the atoms are far as possible. म्हणजेच staggered conformation मध्ये काय होतं की जे ग्रुप आहेत लार्जर ग्रुप असे एकमेकांपासून लांब असतात. तसं इक्लिप्स मध्ये कसं असतंय एकमेकाच्या जवळ असतात. Therefore rotate the front or rear carbon atom clockwise or the anti-clockwise to get the conformation second, as like this. This is second conformation. And hence all hydrogen atoms are opposite in eclipse vicinal hydrogens. On the other hand, they are eclipse conformation. For these energy level diagrams, we can show that the molecules can rotate at 60-degree rotation. They will use like staggered is converted to eclipse, eclipse is converted to staggered, staggered convert to eclipse, eclipse convert to staggered, staggered is converted to eclipse, eclipse is converted to staggered. So these molecules of the rotations at 0-degree rotation, then 60 degree, 60 degree to 120, 120 to 180, 180 to 40 degree, or these types we can rotation to get the various conformations staggered, eclipse, staggered, eclipse, staggered, eclipse. So staggered conformation we see in these energy level diagrams. The staggered conformation has lower energy and hence it is more stable, which is eclipse is a higher energy than staggered conformations, and therefore eclipse is less stable due to it is vicinal hydrogen atoms. They are very close and will experience the repulsive interactions between these two hydrogens. Therefore, it is a higher energy than staggered. Then if we rotate this front carbon at 360 degree in the staggered form and their eclipse forms are obtained, the thrice all staggered forms having the same energy, as like all eclipse also having the same energy. The potential barrier we observe that in these diagrams they show that at this 120 degree, at 240 degree and at 360 degree, right, they will show that is a potential barrier is 60 degree, it is a maximum, and 240, 120 and 360 they will have minimum in energy. Now we have discussed the conformation of butane. Now we have seen structures of butane like this. So 4 carbons are there. So this is a N-butane. So this conformation we can rotate the bond 1 to rotation. So observe 2 conformations are there, like this conformation first, this is conformation second. So if I suggest these conformations, staggered conformations are more stable. N-butane has about these 2 conformations. We rotate along this C1 and C2. We rotate C1 and C2 to produce these 2 conformations. The second conformations, which are less stable because the repulsive force of attraction between the 2 atoms which are near to each other for the ethyl group and this backside protons. N-butane has 6 conformations are possible due to the rotations of C2-C3 bond. This is in between C2 and C3 bond we can rotate. So CH3 group 1 and other CH3 group is present on the other carbons. So staggered conformation, the 3 eclipse which are obtained at 60 degree rotation. One is missing here. So 60 degree rotation. So this C and CH3 bond it attached to same plane and is called as a periplanar carbons and not same plane, which is called as a clinal. If methyl group is close to each other, then prefix can be used as a syn, and away from each other, the prefix Vr is a anti. Now we have discussed this anti-periplanar and synclinal. So anti-periplanar means it is a fully staggered conformations, which is the methyl group are far as possible. Now we have seen anti-periplanar. So this is an anti-periplanar because this methyl group and this is methyl group which are opposite each other. So it is a fully staggered conformation. It is far away to each other, and therefore it has very less energy and maximum stability or maximum stable conformation. Now we have discussed synclinal, the structure third and fifth. Now this synclinal, this is structures gauge conformations, and this is a fifth. So these methyl groups and these methyl groups which are near to each other in staggered conformation. Similarly, these methyl groups and these methyl groups near to each other. Therefore, it produces some interaction between the two groups, and therefore, in synclinal, they methyl group closer to each other by allowed the van der Waals radii. Therefore, these conformations is called as a gauge conformation or the skew conformation. They are higher energy than fully staggered. Now we compare this structure, these and these structures with this anti-periplanar. These methyl larger bulky groups which are opposite each other, but these methyl groups we are nearly to each others, and therefore they can produce some interactions between the two methyl group, and such interactions is called as gauge interactions. Right. Now we have see anticlinal conformations. So structure second and fourth. This is structure second and the structure fourth. Right. Structures the second and structure fourth. They are eclipsed, and therefore it is highest energy is about near to 3.4 kilocalorie per mole. And syn-periplanar, that is the structure 4. This is structure these pores. They produce this large steric repulsion in between these molecules. They are fully eclipsed. These are fully eclipsed conformations, and hence the size of the methyl group are very close to each other, and therefore they will show higher energy and very less stable because it is highest energy up to 4.5 kilocalorie per mole. But at ordinary temperatures they will show predominantly at anti-form. Now we have seen these energy level diagrams. We observe that this is structure first, second, third, fourth, fifth, and sixth structures. We clearly indicate that which is more stable. The structure first is more stable as compared to other structure. Similarly, the structure third and fifth are more stable than the second and the sixth, and structure fourth is very less stable. So for these energy level diagrams, we clearly shows that this which is more stable. So for these 6 conformations are observed, and these 6 conformations shows that the structure first which are more stable by fully staggered conformation due to less energy. Thank you.